Hello everyone, we've solved by factoring. Now we're going to solve using square roots. And I'm going to start with a problem that is factorable. This is a difference of two squares. So we should probably factor out the GCF first because that's a good habit. And now we have x squared is a perfect square and 4 is a perfect square. So you take the square root of both. The square root of x squared is x, the square root of 4 is 2. And remember, 1 is plus and 1 is minus. So if I set each factor equal to 0, x plus 2 equals 0 when x is negative 2, and x minus 2 equals 0 when x is positive 2. If you look at the graph, oh, that's negative 2, that's positive 2. Okay, so great, we know how to factor. What's different? Well, in this problem, because you only have x squareds, you don't have x squareds and x to the first, you don't need to factor, you can solve using square roots. You can treat it just like solving an equation with one extra step where you have to use the square root to help you. So what I'm going to do is isolate the squared term, and what that means in this problem is x squared. I'm trying to get x squared by itself, so I would first add 16 to both sides. Now I have 4x squared equals 16, and then I would divide both sides by 4. So 16 divided by 4 is 4. Now that you have x squared by itself, we have a way to undo squaring. It's called square rooting. So you get x equals, and the square root of 4 is, this is where you need to be very careful. The square root of 4 is 2, but it's also negative 2, plus or minus 2. If you multiply a positive 2 times a positive 2, you will get 4. If you multiply a negative 2 times a negative 2, you will still get 4. So you need to remember that there are two answers. When we factored, we had no problem with that. But if you don't factor and you use square roots, you have to remember, if you ever add a square root to both sides while solving, you have to remember there are two answers, plus and minus. So that's going to be the big thing, is you remember your plus and minus. So this one's going to be pretty similar. I'm going to get x squared by itself. So I will first add 45. 5x squared equals 45. I will then divide both sides by 5 to get the squared term by itself, and 45 divided by 5 is 9. Great, that's a perfect square. So when I square root both sides, I get x equals plus or minus 3. And there are two answers. And I'll show you, if you check it, and I'm just going to plug it in the calculator, like we've done a million times, 5, there's the bell, 5 times 3 squared minus 45. If I plug it in the left side, I should get 0. Yep. And then 5 times negative 3 squared, because a negative times a negative is going to be a positive, it's going to come out to be the same. Also get 0. There are two answers. You must have both, plus or minus 3. That's the symbol we use to say x equals 3 or x equals negative 3. Obviously, it can't be both at the same time. It's either 3 or negative 3. This is just a shortcut. So this one, we'll do one more that's pretty straightforward, and then we'll do some that are a little trickier. Add 4 to both sides. 2x squared equals 4 plus 2 is 6. Divide both sides by 2. X squared equals 3. Well, 3 is not a perfect square, so what I'm going to do is just leave it as plus or minus radical 3. I'm going to simplify that radical, but radical 3 is already simplified, so that's it. Plus or minus radical 3. And you can still check that. 2 times radical 3 squared minus 4. I should get 2. Yep. 2 times negative radical 3 squared minus 4. I should get 2. Sweet. I have two answers. They're just radical 3. The square root of 3 is like 1.7 something, 1.74 I think. Oh, yeah, 1.73. I don't want the decimals. I want exact answers. Exact answers go for, like, this is a decimal that goes forever and has no pattern. It's called irrational. So this is the best possible answer. This is exact. All right, now this is a little fancier. We're still going to isolate the squared term first, but in this problem, the squared term is a binomial. That means it has two terms. So I'm going to treat it similarly to as if I was solving this equation. I'm going to divide both sides by 5. And when I divide both sides by 5, on the left side, this cancels out. And on the right side, so I'm just going to leave that as x minus 7 squared. On the right side, 10 minus 5 is 2. So this is a little trickier. Now, here in this problem, I would have said x squared equals 2, and the next step would be to square root both sides. Well, that's the next step here as well, square root both sides. And when you square root a squared term, you get just the x minus 7. And on the right side, I'm just going to write this as plus or minus radical 2. Now, 2 is not a perfect square. That's fine. Just leave it as radical 2. But we don't have x by itself, and this is where it gets a little funky. We're going to add 7 to both sides, and I want you to write this as a positive 7 plus or minus radical 2. That's two answers. You could think of this as 7 plus radical 2, or you could think of this as 7 minus radical 2. But there are two answers here, and we can write it with a plus or minus. It's just kind of weird at first when you see that. And I want to check this one, because this is important that we understand what's going on here. So where's my calculator? Okay, I'm going to do 5 times, in parentheses, 7 plus radical 2, and then it's going to be minus 7 squared. So instead of x, I'm putting 7 plus radical 2, and if I get 10, I know I did it right. 5 times 7 minus radical 2, and then we have minus 7. Square that, should also get 10. Cool, so there are two answers. It is 7 plus or minus radical 2 is how we write that. It takes a little getting used to, but we're going to do the same thing with the quadratic formula. This is the same idea. You need to get that whole squared term by itself. Here you have an extra step. You have to add 20. So 4 times x minus 9 squared equals 20 minus 4 is 16. We still don't have the squared term isolated. We need to get rid of that 4. So divide by 4. X minus 9 squared equals 4. Now I'm going to undo the squaring by square rooting both sides, and that gives me x minus 9 on the left, and here we have the square root of 4, which is plus or minus 2. Okay, that's nice because that's a perfect square. So now what I'll do is my last step, add 9 to both sides, and you need to write it as 9 plus or minus 2. But since those are nice friendly numbers, I can actually combine those. 9 plus 2 is 11. 9 minus 2 is 7. So the two answers are 11 and 7. And you can check it. You can plug it in. 4 times 11 minus 2 squared minus 20. I should get negative 4. Whoa. That's not negative 4. What did I do wrong? X minus 11 minus 2 is 4 times 4 is 16 minus 20. I think I just typed it in wrong. I think I might have used the wrong button. 4 times 11 minus 2 squared minus 20. Did I use the times? Oh, it's 9. I'm typing it in wrong. Okay, you got to read the question correctly. I'm like, why is this not working? 11 minus 9 squared. I don't know why I couldn't see that. There we go. Now, if I do that, I should get negative 4. Good. 4 times 11, no, 7 minus 9. The other one is 7. Minus 20. Okay, so if I plug in 7 and actually type it in correctly, I should get negative 4. Sweet. All right, I know I did it right. But it is important that you practice checking them, and sometimes you catch mistakes. I did them right, but I just checked them wrong. Let's do the practice problems now. I want to get x squared by itself. So to get x squared by itself, I'll subtract 6 on both sides. Negative 3x squared equals 3 minus 6 is negative 3. Divide by negative 3. Negative divided by negative is positive 1. Square root both sides. The square root of 1 is plus or minus 1. Okay, so plus or minus 1. I'll do the other one like that because those are the easier ones. So to get the x squared by itself, you would subtract 13. 3x squared equals 3. 16 minus 3 is 3. Divide by 3. X squared equals 1. Hey, it's going to be plus or minus 1 again. X equals plus or minus 1. Okay, great. We got plus or minus 1 for both of them. These are the ones that I think are more difficult, so let's focus on that. You're trying to isolate that quantity, so you will first add 11. 3 times x minus 8 squared equals 40 plus 11 is 51. Divide both sides by 3. X minus 8 squared equals 53 divided by 1 is 17, right? Make sure 51 divided by 3. Yeah, okay. Then square root both sides. This one's going to be ugly. x minus 8 equals plus or minus radical 17. But that's not done because we don't have x by itself. Now we need to undo the minus, and that's the very last step. So x equals 8 plus or minus radical 17. It's gross, but it's fine. That's an exact answer. 8 plus radical 17 is one of them. 8 minus radical 17 is the other, which I think that'd be like 12 point something and 3 point something if you actually got them as decimals. Last one, get the squared binomial by itself, so add 24 to both sides. 5 times x plus 10 squared equals 26 plus 24 is 50. Divide by 5. X plus 10 quantity squared is 10. To undo squaring, we square root. X plus 10 equals plus or minus. The square root of 10 is not nice. The square root of 10 is 3 point something. It's a decimal again, so we can't simplify that. But we can subtract 10 on both sides and get negative 10 plus or minus radical 10. Okay. Now those are not like terms. If they don't have the same thing under the radical, you can't combine them. So that is the best you can do. Negative 10 plus or minus radical 10. So make sure you work on that section on your packet and make sure you hit that like and subscribe.